Hey everyone, thanks for being here today. We know that there's a lot of great session going on, so we really appreciate your time, and let's roll. My name is Valentinas. I'm the analytics engineering lead at Hostinger. We're a web hosting company coming to you from Europe.
Hello everyone, my name is Augustinas. I am an analytic engineer at Hostinger.
And as you'll notice during today's presentation, me and Augustinas have a few things in common. We both have accents, we're both under 30, and we're both extremely happy. And as according to the World Happiness Report, Lithuania is the best place to be if you're under 30. So if you're sick of paying high rent, make sure to pay me and Augustinas a visit in Lithuania. We'd love to show you around.
Yeah, and even though Lithuania is a small country, when you look at it on the web, we have a big achievement to be proud of: basketball. We're able to compete with the greatest countries in the world, sometimes even beat them, including the US. You can see the result from the last year's World Championship. So we may be small, but we are tough.
And our pride doesn't stop at basketball. Hostinger has grown tremendously over the past several years, now hosting over 3 million clients and managing over 5 million domains. And it took us 17 years to reach the first million clients, just over 3 years to reach the second, and just under a year to reach the third. And this rapid growth has earned us the title of the world's fastest growing web hosting company. And the secret to our growth is simple. We are relentlessly customer obsessed. And one of the key company-wide objectives over the past several quarters has been to make the first 24 hours for every Hostinger customer a wow experience. And this meant that every team at Hostinger had to align on this goal, and our data team was no exception. And even though we're not a customer-facing team, we knew that we had to contribute meaningfully. So our solution was to ensure that analysts could see and analyze that every single action that the client takes within those first 24 hours. And to accomplish this, we built a robust CDC to SCD data pipeline to ensure that analysts could see and analyze those actions and perform analytics on them. And our solution, the solution that we built and which we'll present today, is anchored in 3 key pillars. First being reliability. So our solution is dependable with consistent and easy to analyze data. Second, and this is a point of pride for me, it's affordable. And pipelines like this can get expensive really fast, especially with the data warehouses such as BigQuery. One of those data warehouses that could bankrupt your company if you're not careful. And third, it's scalability. And scalability is crucial for us. As you saw how fast the company is growing, so 60, 70% year over year, and that leads to exponential data growth. And all of these pillars contribute to better customer insights. But what does this actually mean in our context? So let's step inside a role of a data analyst at Hostinger. We're on the website builder team. And our mission is simple. We want to help the product owner to make sense of how users choose the website builder to manage their website within those first 24 hours. If we look at this example, it seems simple. The client signed up, he created a website, indiemusic.lt, and chose Website Builder as their CMS. Well, simple, right? But not quite. Thanks to our CDC solution, we can see that it actually took the client some time and exploration before settling in on the CMS. And for our product owners, this is crucial information. And throughout our presentation, we'll use this graph to illustrate that much like our client's journey, our own path to success wasn't really straightforward. We had our shares of ups and downs, breakthroughs and downfalls. But ultimately, we arrived at an affordable, scalable, and reliable solution that truly works.
Yeah, so let's start our journey from the beginning. when we talk about CDC, reliability is one of the main things to keep in mind when evaluating CDC process. So without it, first, it's really hard to trust the data when you see inconsistencies. Second, the business decisions made based on this data could be highly questionable. And finally, your relationship with the stakeholder who uses this data will be complicated, and you will receive constant questions. From my personal experience, I know how hard it is to rebuild trust if the stakeholders have a negative experience with the data. Moreover, nowadays, everyone is talking about data accessibility for everyone, including people who don't even work directly with it. At Hostinger, as an analytic engineer, I often receive questions and sometimes even complaints from my colleagues that's outside the data department about why it's so complicated to work with the existing data models. Luckily, with the solution we created, we overcome these hurdles and ensure that each change event is captured and transformed in a way that's super easy to use. But before moving forward, I want to make it very clear. We had a working data loading solution that served our needs well at that time. And for a few years, it was totally acceptable. So in this slide, you can see how our data replication process looked back then. At Hostinger, we have around 15 microservices, each with its own database. And of course, number of microservices is growing. Initially, like many others, we relied on data replication based on updated add field. We used Airflow as orchestrator, which executed custom Python scripts and load all the records from MySQL databases into corresponding tables in BigQuery. So why fix something that's not broken? Well, actually it was. As you might guess, there are many areas where this data replication process can go wrong. So we grouped all these challenges into two main categories, CDC and SCD challenges. And let's quickly go over them, starting with CDC.
Yeah, so first of all, there's the inability to track rows that have been hard deleted. And this means that tables with hard deletes usually don't have a deleted at column, indicating when a record was deleted from the table. The record is actually removed from the table entirely. When using incremental modeling, incremental loading, it's impossible to catch these deletions, resulting in more rows than there actually are. Second, we're not able to see the full picture because we only captured the latest change that occurred between our loading processes. So for example, if we load the data every 30 minutes, and during those 30 minutes, the row was updated 5 times, we would only capture the latest change that has happened. And as I previously mentioned with the indiemusic.lt example, having that full picture is crucial to understand the customer's journey. And finally, developers often use hot fixes, where updates are made without changing the updated at column. So for example, Modestas, backend developer at Hostinger, admitted that during the migration process, they didn't update the updated at column. This caused, in turn, discrepancies between the product database and what we had in BigQuery, and it led to a necessity to do a full sync. And in this situation, Modestas, he set a good example. He came up to the data team, he reached out, and he would let us know that something is off. But in most cases, you realize that something is wrong with the data when it starts to look questionable.
Yeah, so actually, all the issues with the CDC that has been mentioned by Valentinas have a significant impact on why it was difficult to use built-in DBT solution for snapshots. So due to hard deletes, SCD would show more active records than they actually were. Of course, one way to address this is to just replicate the entire table every time. However, this process is very inefficient in terms of time and costs, especially for large tables. But maybe it can be a solution for smaller tables, but I wouldn't say that, because it's very inflexible when you need to make changes for the historical records in an SCD type 2 table. And here's a short conversation to illustrate this. So here's my colleague, Milda. She's a data scientist at Hostinger. And one day, Milda asked me, August, are we able to fix historical snapshots as our current fix still had issues with missing active WebRaw users? And I had to tell Milda, my apologies, Milda, but the time spent on this fix wouldn't outweigh the result. And it's true, because we don't have the raw data needed to recreate a SCD type 2 table after implementing changes. So the only way to update the existing snapshot, the historical records for the snapshot, is to manually adjust the values for the dimensions, as well as valid to and valid from dates. But this process it's quite delicate, and it's easy to corrupt the table and actually just lose all historical information. So as you can see, there were many challenges we faced, which pushed us to search for a better and robust solutions for CDC and SCD. Yeah, and of course, after dedicating some time for searching for an optimal solution that would meet our needs, finally we came with this CDC solution. The beauty of it, that it handles all the CDC challenges that Valentinas mentioned. So going a bit more to details, here's how we're currently capturing data changes in our microservices. So we use Debezium to capture row-level changes from the bin log and convert this information to event streams. So these streams are sent to Redpanda, which has a Kafka connector. So Kafka in this solution handles distribution, storage, and streaming of those events to consumers. And yeah, we're still using Airflow, which currently acts as a consumer, and it takes all the events from Redpanda and writes them into BigQuery. So this solution it's customized, it's flexible, and the most important thing for us, that it allows us to control each step exactly the way we want. Yeah, and we were really excited to finally have a reliable solution for capturing all the actions happening in our microservices and storing them in our data warehouse. Moreover, it was a new chapter for our data analysts, as this is the most accurate CDC data that we have ever had. So our analysts were eager to dive and generate new insights, even from raw Debezium events table. And here's an example of how a Debezium raw logs table look. So as you can see, we have a usual table variables along with Debezium metadata variables that show the event type, its insert, update, delete, or snapshot, if it's an initial load of the table, and the timestamp when the event happened. But despite our initial excitement, we quickly realized that this format isn't suitable for analytics, as our main stakeholders, data analysts, began complaining about the table format. And surprise, surprise, this is where the DBT and the flexibility it provides come into play. So we created custom macros that take advantage of incremental modeling, as well as merge strategy, to build SCD type 2 table from raw Debezium events. And as you can see, that table format it's pretty common. So we have SCD valid from and SCD valid to columns that show the validation interval for a particular row, as well as the isLatest column that we cluster the table on. So this table, the isLatest column, allows us to get the latest state by applying a single filter. And I wouldn't be exaggerating by saying that it's the most loved column for our developers and analysts, as they no longer needed to figure out on how to retrieve the latest record from the table. Now it's very straightforward. You just need to apply a single filter. Yeah, and despite some bumps on the road, the solution's live. It actually works. But before moving forward, some of you might start wondering if something is off with the first part of the graph. And your doubts are valid, because after a significant change in the process, it takes time for people to adjust. And as a result, unexpected things might happen. So long story short, we host Red Panda on one of our infrastructure servers, which is monitored by our site reliability engineers. And a very common problem occurred. We just received an alert that the server was running out of space. So what's the usual solution? The usual solution for this problem is just to clear logs and free up some space. The problem is that in this case, in this particular case, the logs are data, the events that we are gathering. And as a result, as our colleague Justus mentioned in a short comment, all the data was gone. But luckily, it's not difficult to recreate connectors and start collecting data from scratch. So eventually, we have a reliable solution for collecting. Using dbt, transforming raw events into analytical tables, we can detect all the changes that are happening in our microservices. We no longer struggle with recreating SCD type 2 tables from scratch, as we always have the raw data. And finally, our warehouse data ensures consistency between the source databases and downstream systems. And at this moment, we thought that we're actually ready to fully switch to our new solution until we face a reality check.
So we finally have a stable and working solution. Our analysts are happy, as Augustinas mentioned. So what's next? Let's scale this. And just like that, we realized that with great scale comes an even greater BigQuery invoice from Google. Yeah, and in the first week of scaling our solution, our BigQuery costs tripled. And that, of course, didn't go unnoticed by Skirmantas, who's the head of our infrastructure engineering. I don't know if you can see it, but he gave us a friendly public call out. And if that wasn't enough, things got even more interesting when our BigQuery quota kicked in. Yeah, thankfully, of course, we had one. This caused our BigQuery project to just freeze. And as a result, empty dashboards, the dbt models were not running, and a ton of Slack messages waiting for us in the morning. But despite these challenges, we knew that the show must go on, and we were so close. And once again, the solution to our problem turned out to be dbt. At first, we thought we could rely on the static incremental predicates using the isLatest flag. But it didn't deliver the impact that we were looking for. So we decided to switch gears and make the incremental predicates dynamic. And since we had our own custom CDC solution powered by Debezium, we introduced a previous partitioned add column, which helped us to pinpoint which partitions needed updates. And from there, we transitioned to using the updated add timestamp, the column, to partition our dbt models. So this move allowed us to know exactly which partitions needed updating, and it was making a huge difference in controlling our costs. And this was our aha moment. We knew that we finally had the antidote to our affordability issue, and that antidote was dynamic incremental predicates.
Yes, so another thing that we are really proud of is the scalability that we get with the solution. Especially nowadays, when in the technology sector, everything is changing so rapidly. I believe everyone agrees that it's essential to react and act quickly. Moreover, as you saw at the beginning of the presentation, Hostinger continues to grow rapidly. So for us, for data team, it's crucial to ensure that our data processes can adapt to that speed and not become a bottleneck. So scalability is one of our top priorities. First of all, we're really happy with the speed at which this solution allows us to add new data sources. By implementing multiple customized solutions, we can now add a new database and start analyzing data within 20 minutes. And as Valentinas mentioned, we won't go bankrupt while doing it. Even if it's a database, a microservice with 100 tables, which is quite common in our case, dbt provides flexibility to quickly build 100 new analytical tables from raw Debezium events. And yeah, I know that many of you are waiting for us to talk about the real-time data. And it's another feature I'd like to mention with our updated data replication process is the ability to have real-time CDC and near real-time SCD data in your warehouse. So starting from the very beginning, Debezium acts as a Kafka producer, streaming all events from MySQL binary logs to Redpanda. So this gives us real-time data in Redpanda. From this point, we have two options. So first one, load data in batches as we currently do with Airflow. Or second, configure a direct event streaming process from Redpanda to BigQuery. And depending on your choice, you will have either real-time or near real-time CDC data in BigQuery. And of course, if you choose batching, you will have a delay depending on your shadow loading interval from Redpanda to BigQuery. And finally, dbt SCD type 2 model. So if we're streaming all events from MySQL binary logs to BigQuery, the only limitation of achieving real-time data for an SCD type 2 model is dbt model execution time. So depending on your table size and the volume of new events, the latency between the dbt SCD type 2 model and real-time data in BigQuery will vary. However, we believe that having an analytical table with just a few minutes of delay is something to be proud of.
So let's finally look into the diagram of our CDC to SCD pipeline. And we call it the recipe. And if we manage to convince at least one person in the audience to try and do something similar, this is definitely the best time to take a photograph. So to go over, the key aspects are a customized solution to identify the latest timestamp of the existing model. Use this timestamp to retrieve new records from the Debezium logs and provide impacted partitions to the merge strategy based on new events. And the final outcome is then straightforward. We use incremental modeling, dynamic incremental predicates that allows with the merge strategy to set an end dates for existing records that have been modified or deleted and insert new ones. And finally, this CDC to SCD pipeline with the power of dbt ensures that increasing volumes and complexity are handled accurately, providing timely updates to SCD type 2 tables. And to wrap things up, building a reliable, affordable, and scalable CDC to SCD pipeline is essential for us for supporting the customer journey during those first 24 critical hours. Stability and consistency form the backbone for reliability. And as we saw, affordability doesn't mean cutting corners. Tools like dbt enable us to manage those costs efficiently. Scalability, of course, is key as the business grows, ensuring that our solution evolves with increasing business demands. So by focusing on these core pillars, we've set ourselves up to support the business needs both today and well into the future. And so can you. Thank you. So yeah, we have, I think, some time for questions.
Thank you. Do you have any challenges with schema drift with this solution?
Yeah, actually, at the moment, it requires some manual adjustments. We have some alerts that notify us about schema changes in the database side. So with the DBT model, it requires full synchronization when the schema is modified, but we see some possibilities to improve this, and we are planning to make some adjustments in order to handle this automatically.
So is it on the snapshot side, or how's the Debezium?
Sorry, can you?
Is it on the DBT snapshot part you have the challenge, or is it also on the Debezium?
No, from the Debezium side, it's quite easy to detect the changes because it's also coming from the information about it's coming from the bin log. But in order to implement automatically schema handling for the DBT SCD type 2 model, it's quite challenging at the moment. But yeah, I think we'll be able to do it as well.
I had a question as well here. So for the real-time pipeline, how do you trigger your DBT models, and how often do you run them?
So yeah, we triggered the DBT models with Airflow, and we run them as often as 30 minutes. So in these 30-minute intervals, that's enough for our business needs. But we basically run them 30 minutes in these 30-minute intervals. Yeah, sure. So the question was, what about the real-time scenario? So for our business, it's more, I guess for us, it's like a principle to have that real-time, but for the business, our business, the real-time is, currently it's not essential. So, but with this solution, it wouldn't matter because since the data is being processed incrementally with the merge strategy and having that previous partition, that column, that gives us, you could run it at every minute. You would still process just a fraction of the data that's new. So yeah, but for us, real-time, having that real-time data is not essential. I think we've seen more developers starting to use BigQuery instead of, querying the MySQL database to do some, quick debugging or analysis, and they can now trust BigQuery because, it's the same. They would look at their own database, they would look at BigQuery. So we really appreciate that confidence that we're now getting from developers and their engagement in making the data better, both in the data warehouse and in their database.
So if we want near real time, we have to orchestrate the airflow job every 60 seconds.
Yes, I'd say yes. It could be a continuous job, basically.
Just cycle, yeah.
Yeah.
I'm wondering, there was a request or something about like May data to April data or something along those lines being updated. Was that because the old approach to doing these SCDs had problems that it recorded historical data incorrectly, or was it that you guys wanted to reflect changes like that were made after the fact, but apply them to historical instead of like logging the change as like a change from as of today? Did that make sense? I'm asking did people want to make changes to the SCD tables because the SCD was wrong, or because they wanted to change historical data?
For most of the cases, the bad data is coming direct from SQL databases. For example, the example with the DAPRO users. Developers change the logic how the DAPRO user is defined. We just take this data, we run the snapshot model, it catches this information. After that, we realize that, okay, there was some issues, but in order to fix this, it's quite complicated process because you need to manually do everything. We don't have the raw data that we can easily just use a filter, just filter out some incorrect records and rerun the SCD type 2 model in order to get the same information.
Hi. I have a question. I'm curious, how many rows are you ingesting per second? And why would you choose Google BigQuery, which is not really an engine for real-time analytics?
How many records? Oh, it's a good question. Maybe someone from our team may provide an answer, but it really depends on the table. We have some tables with just action logs with, I don't know, probably millions of records within the day, but some cases just in daily updates, 1 record per day for, I don't know, dimensional table in the database. And why we choose BigQuery?
For historical purposes, basically. Like, the company is using GCP, so BigQuery was, for us, it was like we're so used to it, we went with it. But of course, there are better solutions for storing data like this. But yeah, I guess it's more of like...
So I have a follow-up question. Have you looked at single store?
Mm-hmm.
Single store?
No, we haven't.
Yeah, so it's built for real-time analytics, and you can plug directly into Kafka, and you can ingest into table or store procedure.
Okay.
And then you use a partition function, and then you can run your query in real time.
Okay. Thank you for sharing.
Yep.
Hi, great presentation. I'm curious, I've been hearing a lot about tests during this Coalesce. I'm curious if you guys are running any tests on your SCD type 2 dimensions that get outputted.
Yeah, of course. One of the major tests is just to check if there are any overlapping intervals within the SCD type 2 model. So this is the major test that we are trying to ensure. And there are some just usual tests, not all values, and
Uniqueness.
the uniqueness test. But this one with the overlapping intervals, it's the most important for us in order to ensure that we have in the latest partition in the cluster, latest cluster, we have only the unique primary keys. Yeah.
Hi. Can I ask a question? Can you elaborate a little bit on the dynamic incremental predicates that you mentioned?
Yes, so talking about dynamic incremental predicates, it requires some manual adjustments for get merge SQL. It's like built-in macros in DBT. So in order to push that merge strategy to work with the dynamic incremental predicates, it requires some adjustments. But the whole idea is that we are trying to identify the partitions that have been modified based on the new records that are coming from the database, from the bin log. So if we know what was the updated add value for the previous record, we can take that, and this is the partition that has been updated, modified. Maybe the record was deleted. So we are taking this partition, and we are pushing this partition into the merge strategy just to minimize the amount of records that we are scanning in order to make a merge statement.
Just a follow-up for this question. If I understood correctly, you partitioned the target table in order to optimize the merge. But what in a later workload, when someone is analyzing data in that dimension, they want a different partitioning to optimize that analytical workload. What to do then?
Yeah, it's a really good question. Yeah, basically, the partition that we are currently using, it's updated at. It's basically useless for the analyticals, for analysis. But for the most of the cases, it's totally OK for us because for most of the cases, we're using just isLatest cluster to get the latest state of the table. And more important for us, that it helps us to get the same latest state between the different databases. So for example, developers can take one table from one microservice, another table from another microservice, and by using the isLatest column, we ensure that it is the same timestamp when this cluster has been created. So in the milliseconds, we ensure the consistency between the different databases so they can analyze, you can make some checks in order to check whether the status in one database is equals to the record state in another database. But yeah, I agree with you that the partition that we are currently using is basically useless for the analysis because it just provides information when the record was updated.
Yeah, and just to add to this, maybe the use case for our developers is also they really appreciate having the ability to go, cross microservice, because if you're working only in your microservice, you know that there's, so if you're working with H domains, it relies on H resources, for example, so they want to make sure that those states between, so if a domain is active in H domains, it has to be active in H resources, and if there's a stuck status somewhere, the customer then has some interference. So they really appreciate that, and as Augustinas mentioned, so having the same states is crucial for us because developers really rely on that when debugging so just to add, the subproduct of this is that now devs set up alerts on DBT, and we push those alerts to Slack. So if something like this happens, like mismatch of states, they can now set up alerts on DBT themselves and get those alerts if something is off in the microservices. So we're really proud of that this is happening as a byproduct.
Yeah, and as we have the historical records, you can just get back into whatever the timestamp,
One more question.
and it's the same information.
Staying on the same partition by, so to maintain isLatest and valid to timestamp, you need to know when was the previous record. You need to know partition for the previous record, and that not necessarily will be the same partitions of the new one. So do you have some look back parameter, or how do you ensure that you change the previous state of SCD2?
Yeah, so this is where the Debezium and the information that's coming from it helps us. So with the you can show probably as you can see, there's previous partition add column that show the updated add record from the previous record state. So basically, it's just information from Debezium because it provides information about the previous record, how it looked like, and what was changed.
So I think we're out of time. So thank you a lot for your questions, and thanks for being here.